It's all right, isolating a variable. So step one is you want to move all terms without the variable. And that's why we subtracted 2WH and we were left with what's in red. Okay. Then second, we want to find the GCF with the variable. So the GCF of the side with the variable was 2L. So we factored out 2L and we were left with here what's in navy. S minus 2WH equals 2L times W plus H. And then the third and final step is to isolate the variable. So if I'm multiplying by 2, then I'm going to divide by 2. If I'm multiplying by W plus H, I'm going to divide by W plus H. And what I do to one side, I do to the other, and that isolates my variable. Okay, and that's what it's wanting you to do. There isn't a number to plug in. It may then ask you to evaluate. There's no numbers or values to plug in. It just wants you to be able to isolate any variable. Okay. All right. So here we have one person can paint a shed in 3 hours and another person can paint it in 5 hours. How long will it take to paint the shed if they work together? And the other person paints it in 5 hours. How long will it take for them to paint the shed together? So we have our Y1, first person is 3 hours. And our Y2 person is 5 hours. And this person paints how many sheds? One shed every 3 hours. This person paints one shed every 5 hours. So their painting rate, when you're talking about per hour, so shed, oh, that's not how you spell shed. Shed per hour. I don't know why I keep wanting to spell shed in a very strange way. I'm going to write this as a rate. And if I write it as a rate, that makes it my slope. Does that make sense? Yeah. So I can do one shed every 3 hours. That's this person. And then this person can do one shed every 5 hours. So you're looking at what point, if they work together, how fast would they do? So we're looking at, if I come over to my handy dandy calculator and I put in the first person's rate, which is 1/3, one shed per every 3 hours. Second person's rate, which is one shed for every 5 hours. If they work together, I'm zoomed super far out, but let's see. What do you notice happens here? Where is it? It's going to intersect. What am I? Clickety click. Notice if you try to solve in the calculator, they're going to intersect where? At the origin, right? They're going to intersect at the origin because this isn't a problem where you can just say, okay, I'm going to put it together. You're now trying to figure out what is their average speed, right? Their average time. What is the time that these two people together are going to save to do one shed? So